So there is one more topic. One more topic and a calculation. Let's see. Need volunteers. Just wearing a blue shirt. Oh, well, go for it.
Well, I'm just quick writing down the domain and range in the two circles.
Okay, what is your favorite food item?
I suppose human bread. So it's bread.
Bread? Oh, human bread. Okay, that's fine.
Aguano. Really good.
Okay, Lou.
Pizza.
Pizza.
Me? All of them.
Huh?
All of them.
All of them. Well, I'm trying to get to a function.
Yeah, all of you.
So we're going to skip.
Oh, chocolate.
Chocolate. Nothing wrong. One more.
Pasta.
That's it. Okay, so here I took individual people and I asked their favorite food item. So and you guys gave, I asked for one, right? Only one. So because I'm trying to explain a function, if you had two of them, then that would be a problem. So A, likes bread, B, pizza, C, chocolate, D, custard. One value to none. But the reason why we write it this way is to show that you are creating sort of a map from one region to another region. That is what pretty much a function does. So you're kind of going from the x-axis to the y-axis in a plane. So if you wrote all these values as a set, that would be the domain. Yes? If I wrote all values as a set, good, domain, range. No, give me a simple function. X, that works. It's the simplest one I get. I'm going to ask you to give me any number between negative infinity and positive infinity for X. Let's see.
Negative 200.
Negative 200. Okay, Blue.
Negative 5.
Negative 5. What else is wearing too?
Negative 25.
What's up with all the negativity?
Positive.
Positive 25. Okay.
University, what do you expect?
Huh? Wow. Join the club. There are plenty of RSOs around. You will change your mind.
One.
You're not very good.
Well, everyone's colorblind.
You have a point. So, 1. So I picked only 4 values, and for those small values, I'm defining that function. So now plug in negative 200 for x. What would I get?
200.
Negative 200. If I put negative 5, negative 5. If I plug in 25, 25. If I plug in 1, 1. So, you see that connection. So I have defined that function only for 4 values because I asked only 4 people. So in this case, that would be the domain. And that's the range. Formally, I can define the domain. I can look at this and say, this is the set of all x values. Right. But I can't use the word all because I picked only 5 of them. So, would you disagree that this is going to work? If I said that this is going to work, no matter what number you pick, between negative infinity and positive? Would you agree or disagree?
Agree.
You would agree that this is going to work for any value of x. So the domain in general is the set of all possible in this class, it's just real x values. We're only going to talk about the real Cartesian plane, so we'll keep it real. So if I pick every single value of x, I need to have a corresponding possible real value. Then I could include that value in the domain, and I could include it in the range. Piecewise defined functions. Remember, I had 3 different pieces last time, and I said that one interval is the domain for the first piece, the other is the domain for the second, and so forth. This function goes from A all the way up to, infinite. It's going to keep on going. But if I asked you, what is the domain of that piece? A to B, right? Everything between A and B. For this piece, everything between C and D. But it is a continuous function. So going back to y equals x. We agreed that we could put any value of x between negative infinity and positive infinity. So they are all possible values, yes? So if I have to write the domain, in words, I could write it as all real numbers. But as an interval, I can do that. This is the same as saying that. But keep in mind, there shouldn't be a square bracket at negative infinity or close to positive infinity. equivalently speaking, you cannot put less than or equal to when it comes to infinity or negative infinity. That makes sense. Always, a process of elimination. On an exam, if you see a choice that says square bracket negative infinity, that cannot be the answer, period. We'll take our simple functions. I showed you how to graph last time. Let's go ahead and graph these two functions, y equals x squared, y equals x cubed, and using the graph, determine the domain and range for those two functions. What did that look like? This is a parabola. Bad artistry here, it has to be symmetric. But you get the point. So this curve keeps on going this way and that way also. So all of these values are possible on the right-hand side. Same here. It's going to keep on going. All of those values are possible on the left-hand side. So the domain would simply be negative infinity up to positive infinity, right? The range, I could see values here, there, bunches of y values everywhere, including 0. Yes, but do I see any y values here? No, there are no negative y values. So no matter what number you put in that equation, you will always get a positive number. That is true, because if you square a number, you always get a positive number. So the range cannot be negative. No number that's negative, but it can be 0. I can plug in 0. So I'm including 0 all the way up to positive infinity because the curve is going that way and that way. So I will have y values all the way up to positive infinity. So that would be the range. Good. A bit more black on that. Oh. So there are multiple values of x. The curve keeps on going. So I could plug in any value here and get a corresponding y value. Yes. Can't see it, just draw lines. So as you go toward infinity, you get the corresponding y value. Same here, as you go toward positive infinity, you get a corresponding y value. So what is the domain?
All real numbers.
All real numbers, which would be negative infinity to positive infinity. Range. I like to think of it this way anytime I have to determine range. I ask myself a question, do you see something here? Right, in this plot? Nothing. So you can't include the negative. Do you see something here? You do see something, so I will have negative values. So for each of those x values, I have a corresponding y value. So all negative values are possible, all positive values are possible. So negative infinity, positive infinity. Yes,
Why would you use the U symbol?
union.
Oh, yeah.
We will get to that. Good question. Union typically will come into play with piecewise functions.
I thought that had, it was.
Maybe, let's do a problem, since you guys brought it up. This way I can show you how to do it using the calculator also. Another person asked the same question. Okay, I want you to graph this first and then see what x values are possible, what y values are possible. Then we'll go from there. So calculator is your friend. Give it a try, and then I'll explain using the calculator. So I am very glad I picked this problem because some of you had issues. I will demonstrate what that problem is. So my new graph is sum it as x divided by x plus 1 times x minus 1. So if you did it that way, the calculator is assuming that you're doing this. Right? Or the other way around, but that isn't obvious.
There's actually an easy way to do it.
I know.
If you do second y,
Second one?
if you do second y and then you hit the first thing, it'll make it to where it looks exactly like how you have it on the board.
Oh, really?
Yeah,
Oh.
so it'll actually put like.
Second one, wow. I learned something today. Wow.
Yeah, if you just do it right now, just to try it.
So second y, what?
And then the first one.
Yeah, you do second y and then,
So press second
So clear out the whole thing first.
and then y. Oh. The second one?
alpha y, my bad.
Okay.
Alpha y.
Alpha. What?
Oh, alpha.
But you have to be inside the thing, you're like behind it.
So I have to
Like
do
just
this.
go to the one like y2, go to y2.
Okay.
We have to clear it all first.
So do alpha y,
Alpha y,
it should bring up a menu.
alpha.
Oh.
Yeah, it brings up a menu and then you choose n/d. But I don't know if it works on that.
Okay, let's not, you guys can Google this.
Yeah.
I'm gonna show you an easier way. The better way is to put it within parentheses. So, say,
Huh?
And it makes a fraction.
Why? Yeah, it makes like a.
That's-
you convert it into a fraction?
Yeah, it already puts it for a fraction.
Okay, I see. So just put the entire thing within parentheses. He's converting it into a fraction. So parentheses are important. So if you did it directly, so Google second y, and see what it looks like.
Alpha y.
Or alpha y. I don't use the calculator. So this is the sort of graph that you would get, but this is not the graph of that function. So if you have a bunch of terms in the denominator, you have to put them within parentheses. And the entire graph changes, right? There is another easier way. You could use algebra x plus 1 times x minus 1 is x squared minus 1, right? So if I put y2 as x divided by, oops. Nothing's going to happen because it's the same function, right? So previous problem, you guys graph x squared, x cubed. If you graph two equations, one would be on top of the other. Here, nothing's happening because they are the same. Now moving on to the domain and range. We'll talk about these later on. Always ask a question when you see a problem like this. Of course, graphing it using a calculator is the smartest way. So always rely on a calculator when you do that number. But if you know the concept, you will always have a break in the function. And in other words, you have to use u if there is a break in the function. Piecewise defined functions have breaks, by default. This function you may know, you may not know, but the easier way to determine if a function would have a break or not is to see if the denominator could become 0 for some value of x. If I put 1 there, that will become 0. The entire denominator will become 0. So there is a problem at 1. If I put -1 there, that would become 0. Entire denominator would become 0. -1 is a problem. So that number right there is -1. That number is +1. Yes, that's where the break is at. So now I know my pieces. Three pieces, right? This is not a piecewise defined function. This is just a function with a discontinuity. So that would be my first interval. That would be my second interval. And that would be my third interval. Three pieces. If I put them all together, I'll get the entire domain because the function is defined for all of these values. It is defined to get real numbers for all of those values. Function is defined for all of those values also. So the domain, all of those x values are possible. So I start at -infinity, I go all the way up to -1. That's easy. Should I put a bracket or a parenthesis? Why bracket? Why bracket? Someone said bracket. Why bracket?
Because it's an exact length. Instead of it just being a nebulous number like negative infinity and the very least equal to an actual number.
Okay. What do you think?
Hi, Sarah.
Sarah's disagreeing with you. Why?
Because it's the asymptote, then you can't equal like the asymptote.
Exactly. So if you go back a bit, I said I cannot plug in -1 in there. If I put -1, the denominator would become 0. It's no longer a real number. It's just, positive infinity, negative infinity. So I cannot include that. Cannot include -1. How about, let's play -1 and 1. I can't define the function properly. So there is a function between -1 and 1. I start at 1, go all the way up to infinity, I've got the function, but exactly at 1 doesn't exist, or it's not defined. So 1 all the way up to positive infinity. We have 3 pieces, so we put U. Means union. This, that, combined together. The range even I overlooked when I was checking the answer, but then I realized. So this is a curve that's going that way, right? So if you draw it like this, or if the calculator is showing something like this, on this side, it's getting closer and closer to 0, but it will never become 0, right? So I'm going to say negative infinity is 0, but it doesn't equal 0. The same over here on this side. Starts at positive infinity, all y values keeps on going to 0, but it doesn't exactly touch 0. So this is a common mistake. When I said I overlooked it, this is where, as I was checking the answer, I overlooked it. But that's not the answer. You can't simply put union there. Why? The reason being, 0 is a possible value there, right? So since 0 is possible, negative infinity to 0 include, you're including on both sides, which means 0 falls in the middle, so all real numbers. Does that make sense? Right?
So you would just write it at the bottom.
Because you simply look at this, it won't become 0, it will include 0. Same over there. If you look at these two pieces, you would conclude, oh, the function is not going to take on the value 0. But the moment you realize that the function crosses 0 here, you have to include 0. So if you include 0, it will be all real numbers for the y-axis. Does that make sense? Okay. Good.